Welcome everyone to Future Forward, the podcast where we decode the technological shifts shaping tomorrow's business landscape. Today, we're diving deep into a concept that might just redefine artificial intelligence as we know it, the era of experience. We have a fantastic panel of experts with us. We've got deep technical wizards who live and breathe algorithms, and strategic business minds who translate these breakthroughs into market realities. Let's jump right in.
Thanks for having me. It's a fascinating topic. We've seen incredible things with AI lately, especially large language models, LLMs, trained on vast amounts of human text and data. They write poetry, diagnose issues, summarize complex documents. It's really quite remarkable.
Absolutely. From a business perspective, these LLMs have unlocked significant productivity gains and new customer interaction models. We've seen applications across marketing, customer service, R&D. The initial ROI has been compelling for many early adopters.
And this is the crux of today's discussion. The paper we're looking at argues we're hitting a ceiling. It suggests that simply imitating humans, learning from the data we've already created, can only take us so far. It's like we've mined most of the easily accessible gold from the human data mountain.
Precisely, the low-hanging fruit, the high-quality human data that significantly improves these already powerful models, is becoming scarce. Progress driven solely by supervised learning on this static dataset is, well, it's slowing down. We can see the curve flattening in some key areas.
It's the classic S-curve, isn't it? We've ridden the steep part of innovation based on human data, and now we're entering the plateau phase. To find the next S-curve, we need a fundamentally new input, a new fuel source for AI progress.
And that new fuel source, according to the authors, is experience. Expert 1, can you unpack what that means in this context? How does learning from experience differ from learning from human data?
Great question. Fundamentally, it's about agents learning through direct interaction with an environment, rather than passively consuming pre-existing data. Think trial and error, feedback loops, consequences. It's the core idea behind reinforcement learning, or RL.
It's the difference between reading a million chess books written by grandmasters versus actually playing millions of games, discovering strategies no human ever wrote down. The paper cites AlphaProof in mathematics. It learned from existing proofs, sure, but then generated hundreds of millions more through interaction, eventually solving problems at an IMO silver medal level. That wasn't just imitation, that was discovery driven by experience.
And the DeepSeek example, too, highlighting how RL allows models to autonomously develop advanced problem-solving strategies just by providing the right incentives. It's quite elegant, really. Less direct teaching, more guiding discovery.
So this era of experience isn't just about using RL. The paper outlines some key characteristics that differentiate these future agents. Let's talk about streams of experience. Expert 3.
Right, this is a big shift. Current LLM interactions are often episodic. You ask a question, get an answer, and the context resets. Maybe there's some short-term memory, but it's limited. An experiential agent, however, would exist in a continuous stream of interaction, learning and adapting over long periods, potentially a lifetime.
The business implications there are profound. Imagine a personalized health coach AI that monitors your wearables, diet, activity over years, constantly adapting its advice based on long-term trends and your evolving goals. Not just answering, "What's a healthy breakfast?" but guiding your entire wellness journey. Or an education tutor that grows with a student from elementary school through college.
It requires thinking about goals differently, too. Actions might not yield immediate rewards but contribute to long-term success. Like investing, you sacrifice immediate spending for future growth. These agents need to optimize for outcomes far down the stream, not just the next response.
This leads naturally into the next point, richer actions and observations. It's not just text in, text out anymore.
Exactly, the paper talks about moving beyond human-privileged communication like dialogue. Experiential agents need to act in their environment and perceive it through richer sensors. This could mean controlling software via APIs, using computer interfaces like a human does, clicking, typing, dragging, or even interacting with the physical world through sensors and robotics.
We're already seeing the beginnings of this. Models learning to use tools, browse the web, execute code, and learn from the output. That's experiential learning in the digital realm. The next step is generalizing this, allowing agents to autonomously explore and manipulate digital or even physical environments to achieve their goals.
This autonomy is where things get interesting and perhaps a bit scary for businesses. An AI that can independently operate software, run analyses, manage systems. The potential for automation is huge, but so is the need for robust control and safety mechanisms. It's like giving an apprentice the keys to the entire workshop, not just one machine.
Let's talk about the engine driving this learning, grounded rewards. Expert 2, the paper draws a sharp contrast with current methods, right?
Yes, a very important one. Much current AI tuning, especially with RLHF, reinforcement learning from human feedback, relies on human prejudgment. A human looks at the AI's output and says good or bad or ranks options. This is useful, but it's inherently limited by the human rater's understanding and potential biases. You can't really discover something truly novel if your success metric is just, did a human think this was good before seeing the consequences?
It's like judging a chef based on the recipe's description versus actually tasting the dish after it's cooked and served. Grounded rewards are about measuring the actual outcomes in the environment. Did the health AI user's resting heart rate actually improve? Did the student using the education AI actually pass the exam? Did the science AI's suggested experiment yield the predicted result?
The environment itself provides the success signal. The paper lists tons of examples: cost, error rates, health metrics, profit, sales, efficiency, even physical measurements like tensile strength for a materials science AI. The world is full of measurable signals we can use as rewards.
But hang on, this sounds powerful, but also potentially chaotic. If we just unleash AIs to optimize arbitrary environmental signals, how do we ensure they align with complex, nuanced human goals? Optimizing purely for user engagement gave us clickbait. Optimizing purely for paperclip production. Well, Nick Bostrom wrote about that thought experiment years ago. Isn't defining the right grounded reward the Achilles heel here?
That's a critical point, Expert 6. And the paper acknowledges this isn't necessarily about picking one simple signal. It proposes a more sophisticated approach, potentially using neural networks to define the reward function itself. This function could combine multiple grounded signals based on the user's stated goal, like improve fitness, might translate to a weighted function of heart rate, sleep, steps, maybe even user-reported energy levels.
It also mentions a bi-level optimization idea. The AI optimizes the grounded signals at a low level, but there's a higher level optimization based on user feedback about whether the overall outcome is satisfactory. This allows for correction and refinement of the reward function itself over time, based on experience. It's learning what to optimize, guided by human values but grounded in real-world results.
So it's not just choosing a metric, but potentially learning the metric itself. That's meta.
You could think of it as using a small amount of high-level human guidance to leverage a vast amount of autonomous learning from grounded signals. It's trying to get the best of both worlds.
Let's move to the final characteristic, planning and reasoning. How does the era of experience change how AI thinks?
Current LLMs can reason using language, often mimicking human chain of thought. It's powerful, but the paper argues human language is unlikely to be the optimal way for a machine to compute or reason. Experiential learning could allow agents to develop more efficient, perhaps non-human-like ways of thinking, symbolic, distributed, continuous. AlphaProof, again, learn to prove theorems differently than humans.
Crucially, this reasoning needs to be grounded in the real world, not just human text. The paper uses a great analogy. Reasoning based only on human knowledge from 5,000 years ago might involve animism. 300 years ago, Newtonian mechanics. To get beyond current limitations and biases embedded in our knowledge, AI needs to test its reasoning against reality via interaction and observation.
This is where concepts like world models come in. An AI builds an internal simulation of its environment, allowing it to predict the consequences of its actions. If I suggest this gym, how will the user's heart rate likely change? What might they say next? This allows for planning based on causal effects in the world, not just correlations in text data.
It sounds like a return to some classic AI and RL ideas that perhaps got overshadowed by the LLM boom. The paper hints at this, throwing the baby out with the bathwater.
Well, the LLM revolution brought incredible generality, which earlier RL systems often lacked. They were masters of specific games or simulated tasks, but didn't easily translate to broad, open-ended problems. The era of human data solved the generality problem using massive datasets.
But as the paper argues, it sacrificed the ability for true self-discovery that RL champions, like AlphaZero finding chess strategies that changed human play. The era of experience aims to reconcile generality with self-discovery by grounding these powerful models in real-world streams, actions, observations, and rewards. It's about leveraging the scale of LLMs but fueling them with dynamic experience, not just static data.
And that means dusting off and enhancing classic RL concepts, better value function estimation for long streams, more sophisticated real-world exploration techniques, robust world models for complex environments, new methods for temporal abstraction to handle long timescales. It's fertile ground for technical innovation.
Okay, let's talk brass tacks. What are the real-world consequences? The paper mentions personalized assistance, accelerated science. What does this mean for businesses and society?
The potential upsides are transformative. Imagine AI designing novel drugs or materials by running autonomous experiments, iterating far faster than human teams. Personalized education that adapts perfectly. Hyper-efficient resource management. This could drive unprecedented economic growth and solve major global challenges. Think Moore's Law, but for discovery itself.
But the challenges are equally significant. Automation reaching into cognitive tasks previously thought uniquely human, long-term planning, innovation, deep situational understanding. Job displacement is a major concern, and the autonomy itself brings risks. An agent acting over long streams with grounded rewards has fewer points for human intervention. Trust becomes paramount.
And interpretability might decrease, right? If these agents develop non-human ways of reasoning, understanding why they make certain decisions could become much harder. That's a huge issue for compliance, debugging, and building trust, especially in high-stakes domains like finance or healthcare.
Expert 6 raised the alignment issue earlier. Is it all downside risk on the safety front?
Interestingly, the paper argues experiential learning might offer some safety benefits. First, these agents are aware of and adapt to their environment. If the world changes unexpectedly, hardware fails, a crisis occurs, they can potentially adjust, unlike a fixed system. They might even learn to recognize and avoid actions causing human distress.
And the adaptive reward function idea we discussed, if the AI starts gaming its reward signal in undesirable ways, the bi-level optimization or human feedback loop provides a mechanism to correct the reward function itself through experience. It's not foolproof, analogous to how humans adjust goals for each other, but it offers a path for iterative alignment.
Plus, there's a potential natural break. Real-world interaction often takes time. You can't run a million physical drug trials overnight. This might slow down runaway self-improvement loops compared to purely digital or simulated scenarios.
So, a complex picture of immense potential and significant, perhaps novel risks. Expert 6, you looked skeptical earlier about defining grounded rewards. Any other contrarian thoughts? Are we sure this transition is imminent or easy?
I absolutely believe the potential is there, but I think the practical hurdles of bridging to the real, messy world are often underestimated. Building truly robust agents that can handle the noise, uncertainty, and sheer complexity of continuous grounded interaction is a monumental engineering and scientific challenge. It's not just about algorithms, it's about infrastructure, sensing, safety protocols.
I agree. And the cost factor, generating massive amounts of meaningful real-world experience, could be incredibly expensive compared to downloading another terabyte of text data. Think robot interaction time, sensor costs, simulation fidelity. The economics need to work out.
Expert 4, always bringing us back to the budget. A necessary reality check.
It's true, the path from simulated success in games like Go or StarCraft to broad real-world competence is non-trivial. We need breakthroughs not just in core RL, but in sim-to-real transfer, safe exploration, multi-agent coordination in the real world. The list is long.
This has been an incredibly rich discussion. We've journeyed from the limitations of AI trained solely on human data to the dawn of a potential new era of experience, where agents learn, adapt, and discover through continuous, grounded interaction with the world. We've touched on the defining characteristics, streams of experience, rich actions and observations, grounded rewards, and novel forms of reasoning. We've explored the technical underpinnings, the revival of RL concepts, and wrestled with the profound consequences, both the exciting possibilities and the serious challenges, including safety and alignment. As Peter Drucker said, the best way to predict the future is to create it. It seems the AI community is actively trying to create this future, moving beyond imitation towards genuine discovery. The implications for every business leader and technologist listening are immense. My deepest thanks to all our experts today for sharing their insights and navigating this complex terrain with us. This conversation is definitely not episodic. It's one that will continue in a stream for years to come. That's all for this episode of Future Forward. Join us next time as we continue to explore the frontiers of technology and business. Thanks for listening. Artificial intelligence may be entering a new era defined by learning from experience. Current artificial intelligence often learns from massive amounts of human-generated data. This approach using human data is reaching its performance limits. It likely cannot achieve superhuman intelligence across many important tasks alone. High-quality human data sources are being rapidly consumed. The next significant progress requires a new source of data generated by agents themselves. This involves agents learning continuously from interacting with their environment. This shift marks the beginning of the era of experience. Agents in this era will learn from ongoing streams of interaction, not just short episodes. Their actions and observations will be richly grounded in their environment. They will learn beyond simple human dialogue or text interaction. Rewards guiding agent learning will come directly from environmental outcomes. These are called grounded rewards, differing from rewards based only on human judgment. Grounded rewards allow agents to potentially discover strategies unknown to humans. Agents may also plan and reason using methods different from human thought patterns. They might build internal models of the world based on their experiences. This allows planning actions based on predicted real-world consequences. Reinforcement learning methods will be crucial for this experiential learning. Classic reinforcement learning concepts need adaptation for these new challenges. Experiential learning could unlock unprecedented capabilities and accelerate scientific discovery. Personalized assistance could adapt to long-term health or educational goals. However, this era also presents significant risks and challenges. Increased automation could lead to job displacement. Autonomous agents operating over long periods raise new safety concerns. Interpretability might decrease if agents reason differently from humans. Yet, experiential learning might offer some safety benefits. Agents could adapt behavior based on environmental changes or human feedback. Misaligned reward functions might be incrementally corrected through experience. Real-world interaction inherently takes time, potentially slowing down rapid changes. Ultimately, data from agent experience may surpass human-generated data in scale and quality. This paradigm shift promises to advance artificial intelligence towards superhuman abilities.